Good morning, children. How are you? I hope all are very well. Welcome to online classes. My name is P. Deepthi, working as Physical Science CRT, KGBV Anantapur Minority, Kurigunta. Children, we are already learned in yesterday class, in 8th class Physical Science, first chapter, force. So, you know that what is force? Types of force. Children, forces are two types. One is contact force, another one is non-contact force. Children, today in this class we have discussed about non-contact force. Non-contact force is also called as force at a distance or is also called as field force. Children, first of all, what is non-contact force? Children, observe this figure carefully. In this figure, the bar magnet surrounding arrange the magnetic complexes. So here the needle of the complex changes its direction without any physical contact with the bar magnet. But a force must be acting on the needle. Children, observe carefully. Here the bar magnet and magnetic complex not physically contact, but a force must be acting on the needle. So the needle of the complex change its direction. So in this activity, what do you say? So in this activity, the force which occurs without any physical contact between two objects is known as a force at a distance or field force, is also called non-contact force. So, the definition of non-contact force: the force which occurs without any physical contact between two objects is known as a force at a distance or field force. It is also called as non-contact force. Children, today we have learned about three types of non-contact force. So, first one magnetic force, second one electrostatic force, third one gravitational force. First of all, magnetic force is a non-contact force. So, how can we say that magnetic force is a non-contact force? So, I will explain with an activity. I will prove that magnetic force is a non-contact force. Children, observing the magnetic force. Here, I take a swing needle, rub it with bar magnet several times, always moving in the same direction. After some time, the needle gets magnetized. So, the needle always acts like a magnet. With the help of a magnetic compass, so we can identify the north and south poles of the needle. So I will take two color foam ball. One is orange colored, another one is yellow color foam ball. So here pin orange colored foam ball to the south pole and yellow ball to north pole of the needle. Make another needle in the same way. Then drop it in a bowl of water. So what will happen here? Yes, it floats on water. Both needles are floats on water. Float both the needles side by side such that like ends facing each other. So what happens to the needles in such a way that unlike ends? Unlike ends means orange ball of first needles and yellow ball of second needle face each other. Now observe what happens this time. You have already learned, children, in a 6th class we already learned properties of magnets. So do you remember that? Yes. Like poles of two magnets repel each other and unlike poles attract each other. We can observe the orange end of one needle and yellow needle of another needle attract each other and ends with same color repel. Now we know that like poles repel or push each other and unlike poles attract or pull each other. This action of pull or push arises due to a magnetic force. Here carefully observe, a magnet can attract or repel another magnet without contact. So magnetic force is a field force. So magnetic field is a field force, is also called non-contact force, is also called as force at a distance. Next, another type of non-contact force is electrostatic force. Children, how can we say that the electrostatic force is a non-contact force? I will explain with an activity. I will prove that electrostatic force is a non-contact force. I take a comb. Now I take a white paper. Now cut a paper into small pieces and place them on the floor. Rub the comb with a paper and bring the comb near the pieces of papers. What happens now? Are the bits of paper pulled towards the comb? Why does the comb pull or attract the pieces of paper? Here When the comb is rubbed with a paper, the comb acquires an electrostatic charge on its surface. The comb is now said to be a charged body. When it is brought near the bits of paper, the pieces acquire opposite charge and will rise and cling to the balloon. So, finally, the definition of electrostatic force: the force exerted by a charged body on another charged body is known as electrostatic force. In this activity, the comb and pieces of papers without physical contact. When the comb is rubbed with a paper, it acquires an electrostatic charge on its surface. So, the comb is said to be a charged body. When it's brought near the bits of paper, the pieces acquire opposite charge and will rise and
Sling to the
cling
balloon.
to the comb. So, in this activity, in the comb place, we alternate, we take balloon also. In same this manner, balloon rubbed with piece of papers. Now cut a paper into a small pieces and place them on the floor and rub the balloon with a paper and bring the balloon near the pieces of papers. So, here balloon is rubbed with a paper. It acquires an electrostatic charge on its surface. The balloon is said to be a charged body. When it's brought near the bits of paper, the pieces acquires opposite charge and will rise and cling to the balloon. So, here the balloon and pieces of paper without any physical contact, the pieces are attracted by the balloon. So, the electrostatic force is a non-contact force. Another type of non-contact force is gravitational force. It is our common experience that if a pen slips off from our hands, it falls down to the floor. Why does the pen fall down? What is the force which pulls the pen down? If you keep the same pen on a table, it does not fall down. Why? Generally, our answer would be that the table supports the pen. If the table does not support the pen, it would fall down until it is supported by another object like the floor. I ask some questions. Why does a stone thrown up into the sky fall back to the earth? Why do rivers flow down to the sea? How does the earth hold the atmosphere? Is there any force pulling the objects towards earth? So, if any object is thrown upwards, there exists a force which pulls it down towards the earth. Because of this, it falls down to the ground. We call this force as a gravitational force. Every object on the earth or close to the earth will experience a gravitational pull. The force of gravity is not just due to the attraction of the earth. It is a force of attraction that existed between any two bodies everywhere in the universe. For example, when you sit in your classroom, will be a gravitational force between you and your teacher, and a similar force existed between you and the blackboard. As the earth is so massive and all the other objects close to the earth are attracted or pulled towards it, so the gravitational force is non-contact force, is also called as force at a distance, is also called as field force. Definition of the gravitational force. The attractive force between any two massive objects is called gravitational force. Concept of field. I will explain with an activity. Visualizing magnetic field. Children, observe here. I take a bar magnet, put it on a table. I take a white drawing sheet, place it over the bar magnet. Now take some iron filings, sprinkle them on the paper. Children, what do you observe here? In this activity, we observe that in a small space around the magnet, iron filings set themselves in a pattern because they are affected by the magnetic force of the field created by the bar magnet. So, the pattern represents the magnetic field. The space around the magnet where its influence can be detected is called the magnetic field. A magnetic field is a region in which a force can be experienced by another object placed at any point in that region. A body creates a field and another body experiences the force by the field when it is placed in that field. For example, a magnetic field surrounds a magnet, an electric field surrounds electric charges, and a gravitational field surrounds masses. The strength of a field in a particular region can be represented by field lines. The greater the density of lines, the stronger the forces in that part of the field. Children, I hope understood. Thank you.